Here we'll be looking at a difference between light construction houses and heavy construction houses. Now remember, light construction houses have wood siding, sheetrock on the outside, and then just regular old wood shingles on the roof. Now heavy construction has stucco on the outside and plaster on the inside, and also regular old shingles. Now remember, stucco and plaster, they're basically concrete, so they're really, really heavy. And for that reason, they need more retrofit components, because as the earthquake shakes, it's just more mass is moving back and forth, and it takes more resistance to handle that. So the way this is done is it just needs more retrofit components. So we're just going to look at the L90s right here. So if you look at the L90s right here, you see that you need 34 as compared to 25. Now that's just to compensate for the weight of the building. That's all that is. So what I hope to show is that for these Cripple walls, if it's made out of stucco, you probably need even less than the light construction houses. And we will see that by actually looking at actual evidence. I'm the sort of person who does not look at tables, who does not look at computer models. I like to look at the evidence, and I plan on showing you some evidence. Let me tell you how I discovered this. I was making a video of houses where the Cripple walls had collapsed, and I found about 50 of them on the internet. You know, I looked pretty hard. I looked in every library I could find. And when I put them all together to make the video, I was startled, because when I looked, I saw that not a single house had stucco. Every single one of them had horizontal boards on it. That we call wood siding. And so I was wondering, why is that? And so I looked into some old building codes, and I found this. This is an old table from the building code, and where it says here, floors with straight tongue and groove sheathing, 100 pounds per foot for seismic shear. So that means, this is for flooring. So, when you look at a house and you just see a bunch of boards that are straight with no oak overlay, what it's saying is that can resist 100 pounds per linear foot. And that's the exact same thing as siding, except for siding it's vertical, and for floors it's horizontal, but it's the exact same thing. So that's, that's pretty weak. 100 pounds per linear foot is, that's pretty weak. And then I went and looked at stucco. And so right here, when it says plaster on wood or metal lath, well, plaster on metal lath, that's the exact same thing as stucco. They don't use the term stucco, but that's what it is. So when I looked at that, it had 200 pounds per foot for seismic shear. So that means that, it's twice as strong. So the stucco obviously, did a whole lot better than the wood siding. So that made a lot of sense to me. And for some reason, stucco, it just holds up better overall. It's supposed to be more brittle, and it's supposed to be something that once it fails, it collapses 100%. But apparently, the stucco holds up a whole lot better. It's probably because of the chicken wire. I'm not really sure. But in any event, stucco holds up a lot better. Another factor that can cause the houses with horizontal wood siding to fail is the fact that, at some point in the past 100 years, and we work on houses that are 100 years old, someone didn't paint it. There was some neglect, and the house ended up coming into disrepair. And so if you don't paint it, then all the nails rust out. And if the nails rust out, it probably goes from 100 pounds per linear foot to only 50 pounds per linear foot, which is clearly insufficient. And that's another reason why we probably see the cripple wall failures only occur in the houses with horizontal siding. I happen to know some things about this table that most people will be unaware of. In the early 1970s, the National Science Foundation gave the Structural Engineers Association a large grant in which they could test existing building materials. And so what they did is they built floors and they built walls and they tested concrete that was just like existing concrete. And so what this is these are actual tests of these existing building materials, because what they did is they actually built walls and they built floors that were just like they find in existing buildings. And they were very fortunate because an actual rocket ship testing laboratory let them use that laboratory, and that laboratory could mimic a earthquake almost identically. So we know that these test results are accurate. Now the reason I know this is the engineer who trained me, who's very old now, he's in a nursing facility, he's the one who told me about this. Let's apply this table to a typical 1,200 square foot heavy construction house. Now heavy construction means that the exterior walls are made of stucco, and that stucco is placed over chicken wire, which holds it in place. Now the interior plaster walls are made of wood lath, and wood lath simply are some really thin, narrow boards that are put one after another with a big gap between them, and then they also have a thin layer of concrete put on top of them. So these are pretty heavy houses. They actually weigh 50 pounds per square foot. Now if we look at the long walls, the cripple walls can resist 10,000 pounds per linear foot. So we take that 50, we multiply it by the 200 pounds per linear foot resistance, we end up with 10,000 pounds of resistance on the two long walls. Now for the short walls, it's the exact same thing. We multiply 25 times 200, and we end up with 5,000 pounds of earthquake resistance on all sides. Now when we do the calculations for this house, we discover that we only need to resist 5,580 pounds of earthquake force on each side. So, where we can resist 10,000 pounds, we're doing great. We have actually almost twice as much as we need. And if we look at the shorter walls, the 25-foot walls, we're pretty close. So that's the reason why stucco houses, at least that's the only reason I can figure out, that's the reason stucco houses do so well and why the cripple walls don't collapse. As you saw, houses with stucco siding do really well. The cripple walls do not collapse. And I was also able to show you that according to engineering calculations, which are part of the old building code table that I showed you, there's a very rational reason why that is. So, a house like that with cripple walls and covered with stucco, a single story, we were looking at a single story here, are very earthquake resistant as is. And frankly, if I was a little short on money, I wouldn't bother to retrofit it. I mean, because empirically, based on evidence, it probably won't collapse. Now, from an engineering point of view, in other words, the engineers, when they were putting FEMA P-1100 together, they're just assuming that these houses have zero earthquake resistance. So they look at the house that they would want to retrofit, and they figure out how much force it's going to be, and then they figure there's absolutely nothing there. There's no nails, there's no stucco, there's no nothing. They just look at the weight of the house. And so what happens with that is you end up over retrofitting everything. Everything is overbuilt, over retrofitted. And when we do that simply from engineering calculations, what happens is we make it so overbuilt that nobody can afford it. And that's what happened with FEMA P-1100. So it would really be good if in the future, if research was done to see how strong the existing houses are. For example, with me, For me to take stucco off of a wall, I know it's pretty damn strong because I've had to take it apart. Same with plaster walls. When we take them apart, man, they are very, very earthquake resistant. They're certainly contractor resistant. It's really hard to get them off. So this also needs to be taken into consideration. And if it were taken into consideration, these FEMA P-1100 retrofits would not be as expensive as they are.